Alright, today we're going to be taking a look at comparing and ordering positive and negative rational numbers, looking at fractions, decimals, as well as integers. The most important thing to remember when we're comparing or ordering rational numbers is that we want to write them in the same form. That's going to give us the best and clearest picture when we are comparing. For example, if we're comparing fractions, we want to find a common denominator in order to compare them. This could be the least common denominator, but really any common denominator would work. Remember, the least common multiple, or the LCM, of two numbers is the smallest number other than 0 that is a multiple of both numbers. So for example, if we were to do 3 and 5, we could do multiples of 3 would be 3, 6, 9, 12, 15, 18, 21, whereas 5 would be 5, 10, 15, 20, 25, and so on. But here, the smallest one, or the first one they have in common, would be 15. Now let's take a look by comparing fractions by finding a common denominator. So for example, if we're comparing 5 sixths and 7 tenths, we're going to find a common denominator. Well, with 5 sixths and 7 tenths, 60 would be a common denominator, but a smaller one would actually be 30. So to change 5 sixths to 30, I'm going to multiply the top and the bottom both by 5, in which case I have 25 30ths. And I'm going to do the same thing with 7 tenths, except for here I'm going to multiply each by 3, and then I get 21 over 30. So here, 25 is greater than 21, so 5 sixths is greater than 7 tenths. So, as I was saying though, so 30 was the least common denominator, but I could have actually taken 5 sixths and multiplied each by 10, which would be 50 over 60, and compared it to 7 tenths, multiplying each by 6, in which case we would get 42 over 60. Still the same answer, and that would be the common denominator. Alright, now it's your turn. Why don't you go ahead and find a common denominator and try this one out. So we're looking at the least common denominator if we can, although in this case, because it's 3 and 5, it's going to work the same way either way. So I'm going to multiply each by 5. 2 times 5 is 10, 3 times 5 is 15. 4 fifths, I'm going to multiply each by 3. And I'm going to get 12 fifteenths. So in this case, 10 fifteenths, because 10 is less than 12. So 2/3 is less than 4 fifths. Now sometimes we're also going to be comparing fractions to decimals. So here we have 44 hundredths, but it's a negative, and then negative 2/5. Now I personally prefer to compare decimals to decimals instead of fractions because you don't have to worry about the common denominators. So here I know that 2/5 is the same as 4 tenths, but now it's going to be a negative because this was a negative answer. So if I compare 44 hundredths to 4 tenths, which is really going to be 40 hundredths, now our tendency would be to say that the 44 hundredths is greater. However, because we have those negative signs, the 2/5 is going to be the bigger number. So that's something to keep in mind as we're comparing with our negatives. So negative 2/5 is our bigger number because it's closer to 0. Alright, 1/9, same type of thing. This is going to be 0.1 repeating, whereas the other one is just 0.1 or 1/10. So if I compare 1 repeating to 1/10 or 10 hundredths, 1/9 is going to be slightly greater than 1/10. Alright, so now this one is your turn. So go ahead and compare 4 and 2/9 and 4 and 3/5. So here we have 4 and 2/9, which is going to be 4.2 repeating. And then we have 4 and 3/5, which is going to be 4.6. since our whole numbers are the same, we're going to just compare our fractions, or our decimals. And in this case, the 0.6 is going to be greater. Okay, we could have also found a common denominator, in which case 2/9 I could multiply each by 5, and I'd have 10 over 45, and then I could take 3/5 and multiply each by 9, in which case we'd have 27 over 45. Another way I like to compare fractions too, if you don't want to do as much work, is like here, I know that half of 9 is 4.5 and 2 is less than half. Half of 5 is 2.5 and 3 is more than half. So I knew that 3/5 was more than half, 2/9 was less than half, therefore the 3/5 would have to be the greater number. To order fractions and decimals, you can either write them all in the same form and then compare them, or place them on a number line. Now let's look at a real-life application. The numbers 14 over 4, -3 and 4/10, 6, and -2 and 5/10 represent the percent of change in populations for 4 states. We want to list these numbers in order from least to greatest. Now, one method we can do this is by placing the numbers on a number line. So if you look below, they're actually already on the number line, and we're going to read them from left to right. So here we have -3 and 4/10 is going to be less than 2 and 5/10. And then 14/4, which is the same thing as 3 1/2, is going to be less than 6. So here we would just read them from left to right. So you can see below -3 and 4/10, then -2 and 5/10, 14/4, and then 6 would be our greatest. So now it's our turn. It's the same idea. We're going to order the numbers 7/2, 3, -2 and 2/10, and -3 and 9/10 as a percent of change for 4 states. We're going to list these numbers in order from least to greatest by placing them on a number line. So here, 7/2 is the same as 3 1/2. So that's going to be my first point that I plot. So this would be my 7/2. 3, I'm just going to change the color. It's going to be right there. So that's our 3.0. -2 and 2/10 is going to be about right here, because remember it's going to be further left. So this is -2 and 2/10, and then -3 and 9/10 is going to be almost to 4. So now when we order these from least to greatest, we can check right below. -3 and 9/10 is the furthest left. Then we have -2 and 2/10, then we have our 3, and then our 7/2. Now we could have also compared them by writing them all in the same form, either all as decimals, that's probably the easiest. But the number line is important too, so you can actually see where the numbers are lining up in comparison to one another, which can be especially helpful when we're looking at negative numbers, because it's easy to get mixed up as to which is the bigger number when you're working with negatives.